Right. Good morning. Good morning. Sorry, I have shared the link in the wrong group. When Tessini asked also, I thought that yesterday only I shared it no කියලා මම බැලුවා. ඊට පස්සේ තව අය අහලා ඉවලා තිබුණා. එතකොටයි දැක්කේ I had shared it in the wrong group. 2025 grade 11 group එකට තමයි දාලා තිබුණේ. Sorry. ගොඩක් අය අඩුයි තාම. මම උදෙත් කිව්වනේ paper class එකේ තියනවා කියලා. ඉතින් මම I didn't think. Actually that's a mistake. Mine. I had added it to the wrong group. ඊයේ තමයි links ටික දැම්මේ other classes වල. ඉතින් 10ට තියනවා කියලා දැම්මා. මම හිතුවා මොකද කියලා. බලමු අනිත් අය join වෙයිද කියලා. We will go through the things that we had started discussed. So about mixtures, the homogeneous and heterogeneous mixtures, and also we mentioned about the different types of different factors affecting the solubility of a substance, right? The nature of solute, nature of solvent, and the temperature, and the different types of chemical compounds, then how they affect the solubility, right? Like dissolve, like organic, polar, non-polar, inorganic, polar, non-polar. So then we started to discuss about the composition of mixtures, right? Composition of mixtures, how the composition affects. What is the importance of expressing the composition exactly? Hari, then videos on karannako. So we discussed different methods like M over M, mass fraction, volume fraction, and also the molar fraction also we discussed, right? Am I correct? අපි කතා කළානේ the molar fraction. Yes, Ranu? We did that part also. Am I correct? Yes. Molar fraction. කිව්වනේ? Yes, Chaneli. We did the third one also. Molar fraction. Mass fraction we did. Volume fraction we discussed. We did the calculations and we did the calculations on molar fraction. How the ne? Hari. Ko videos on karan. Only 4 of you are visible. Yes. The composition of mixture as a mole fraction, N over N. We did those calculations. Oh, ne? Then we mentioned that the sum of mole fractions of all the components, sum of mole fractions, sum of mass fractions, and sum of volume fractions, these are equal to 1, right? And for all these three there are no units. එම කියලා තමයි නැවැත්තුවේ නේද? Then hari, yes, Sri Bhanuja, Adisha, Shenela, Andrea, Gavisha, can you turn on the video? I think the others may have got the message by now. ආයේ එහෙම දවසක වුණොත් පොඩ්ඩක් කලින් message එකක් දාන්න, right? අද මම දැන් දැක්කේ. So I also will be careful to put the link in the correct group, right? Hari. The composition of a mixture expressed as a fraction can also be expressed as a percentage or as parts per million or parts per billion ppm, ppb, right? So we'll see how to express a fraction as a percentage. ඔයගොල්ලෝ දන්නවා දැන් when you are calculating your marks also you do that, right? If you get 16 out of 20, you can convert it into 100. That is as a percentage, right? As a percentage. Okay. So composition as a percentage, fraction into 100. Then composition as parts per million. You know million is 1 into 10 to the power 6. So fraction multiplied by million, 10 to the power 6. Right? Hari. So here you are given two calculations. Percentage as percentage තමයි දෙකම අහන්නේ. Then parts per million වලින් express කරන්නේ when we need to express something, a composition in which the a substance in which the composition is very low. A heavy metal added to a water body, so that heavy metal composition is very low. So if we express it as a percentage, that will be a small value. Therefore, we use the unit parts per million. So if we take million parts of water, how many parts of the heavy metal is available? So the fraction is multiplied by million, 10 to the power 6 for that. Okay. Do these two calculations. So first take the fraction and then multiply by 100 to get the percentage. Kian Balan. 10 grams of magnesium oxide contains 6 grams of magnesium. Since both are given as masses, we can calculate the mass fraction, right? Mass fraction. Calculate the mass fraction of magnesium and express it as a mass percentage. Mass fraction. So the mass of magnesium divided by the mass of magnesium oxide, that is 10 grams, right? So here you can express this as 6/10 එහෙමත් නැත්නම් 0.6 කියලා කිව්වත් කමක් නැහැ. fraction එකක් නිසා we can keep it like this even. මෙහෙම තිබ්බත් කමක් නැහැ. නැත්නම් 3/5 5. Then since we are going to calculate the percentage, I kept it like that. Mass percentage. So you have to multiply the fraction by 100. Then you will get the percentage. Right? That is 60%. 60%. Okay? හරි නේද? මෙතුජ පරක්කු වුණා නේද? ලින්ක් එක දැක්කේ දැන්ද? මම වැරදි group එකටනේ link එක ඊයේ දාලා තියෙන්නේ. Yes, Andrea, Kashvi, Tisas, Adisha, Sribhavanuja, can you be visible, please? Last week, sorry for the late notice. I couldn't conduct the class. I cancelled both classes on Friday and Saturday since I got a throat infection. හරිද සද්දේ ආවෙම නැහැ ඉතින් තාම පොඩ්ඩක් සැරින් සැරේ අඩු වෙනවා. ඒ හැබැයි දැන් හොඳට කතා කරන්න පුළුවන්. So last week actually there was no voice. 40 grams of sodium hydroxide contains 16 grams of oxygen. Calculate the mass fraction of oxygen. Mass fraction of oxygen and express it as a mass percentage. එතකොට mass of oxygen divided by the mass of sodium hydroxide, that is 40 grams. එතකොට 4 into 4, 4 into 10. So you can express it as 4 over 10. Right? Then as a percentage, mass percentage, mass percentage equals the fraction multiplied by 100. That is 40%. 40%. හරි නේද? On then you know how to express m over m, v over v, n over n, then as a percentage. And even if you are asked to present it as ppm, parts per million, you know that is the fraction multiplied by million, 10 to the power 6. හරි නේ? Then we are moving on to the fourth method, expressing the composition of a mixture in terms of mass over volume, m over v. This expresses the mass of solute contained in a unit volume of the mixture. දැන් මෙතන units වෙනස්. කලින් m over m, v over v, n over n, same type. But here m over v, the mass of solute contained in a unit volume of a mixture. Right? So the composition of solute equals mass of solute. Mass of solute divided by volume of the solution. Volume of the solution. Right? Volume of the solution. So if we consider the SI units මොනවාද? Yes. SI units ගත්තොත් the mass is in kilograms. Volume is in cubic meters. Therefore, it is kilograms per cubic meter. That is the SI unit. But in chemistry, in the calculations, most commonly used unit is grams per cubic decimeter. Mass taken in grams and volume taken in decimeters. Right? Grams divided by cubic decimeters. Therefore, it is equal to grams per cubic decimeter. That is most commonly used. You know 1 cubic decimeter is equal to 1 liter, right? Then 1 cubic centimeter is equal to 1 milliliter. So 1000 cubic centimeters is equal to 1 cubic decimeter. Likewise, 1000 milliliters is equal to 1 liter, right? Unit conversions also should be familiar. Hari, do the calculation. I have put one cover up session to cover the session we missed last week, and another extra session during the holidays, right? Please refer. We will move on to after this we will move on to the fourth unit, and we'll start the fifth unit as well, which are very important, especially the fifth unit, in which you will learn how to draw the ray diagrams, right? Therefore, just refer the schedule and join. Also, it's finished. Videos on කරගෙන වැඩ කරන්න පුතේ. Let's see. Let's see. 1 cubic decimeter of sodium chloride solution contains 10 grams of sodium chloride. Find the composition of sodium chloride in it in terms of M over V. So we can write composition in M over V, that is equal to mass of sodium chloride, mass of sodium chloride divided by the volume of the solution, volume of solution, volume of මට මෙහෙම ලියන්නත් පුළුවන් sodium chloride aqueous කිව්වම අපි දන්නවා it is the solution කියලා aqueous solution, right? You have written in words, it's okay. Hari. The mass of sodium chloride is 10 grams divided by 1 cubic decimeter. 1 cubic decimeter. So it is 10 grams per cubic decimeter. 10 grams per cubic decimeter. So don't forget to put the unit. Okay. Then 2.5 cubic decimeter of salt solution contains 50 grams of salt. Find the composition of salt in it in terms of M over V. And once again we can say composition M over V equals mass of salt divided by the volume of the salt solution. Volume of solution. So it is 50 grams divided by 2.5 cubic decimeters, right? And 5 into 10, 5 into 0.5. And 100 divided by 5 again. 100 divided by 5, that is 20 grams per cubic decimeter. 20 grams per cubic decimeter. හරිද? හරි නේද? ප්‍රශ්න නෑනේ මේවා. ඊළඟට ඔන්න අපි යනවා the next method, the method in which most of the questions have been asked and somewhat complex, not complex actually, somewhat complex when compared to the other 4 methods, right? That is concentration. Number of moles divided by the volume, N over V. Right. Expressing the composition of a mixture in terms of number of moles divided by volume. This is what we call as the concentration. This is used to express the composition of a homogeneous mixture. Yes. So, you know, homogeneous mixture in a liquid state is known as a solution. So, this is most probably used to express the composition of mixtures in actually solutions. That means the solute has been fully dissolved, homogeneous mixture, and the composition is uniform throughout. Salt solution, sugar solution, potassium permanganate solution, copper sulfate solution, right? Sodium hydroxide solution. The composition is given in terms of mole is the you know the term mole. You have calculated the number of moles. It is used to, it is the international unit of measuring the amount of substance, right? Amount of substance. The composition is given in terms of amount of moles of solute contained in a unit volume of solution. Number of moles of solute divided by the volume of the solution. In chemistry, the composition expressed in this way is called the concentration. Concentration can N over V, right? C equals N over V. concentration equals number of moles of solute. Number of moles of solute. Number of moles of solute divided by the volume of the solution. Volume of the solution. Right? If we consider the units, in chemistry, very often concentration of a solution is expressed in terms of the amount of moles of solute contained in a cubic decimeter. Right? Very often that is used. Itana tapi SI units gathot moles per cubic meter and SI unit. එතකොට moles per cubic meter is the SI unit. ඔන්න එක සැරයක් මේක අහලා තිබුණා. SI unit is moles per cubic meter. හැබැයි අපි most often we use this moles per cubic decimeter unit. හරිද? එහෙනම් you can underline this. Moles per cubic decimeter is the commonly used symbol. Commonly used one is this moles per cubic decimeter, but the SI unit is moles per cubic meter. Hari neda? So here you have to calculate the number of moles, then divide it by the volume of the solution. Okay? Yes? Videos on karana Limansa, Sandi, Sriba Anuja, Adisha, Ashvi. කවුරු හරි පුතේ අද link එකේ issue එක නිසා පරක්කු වෙලා join වෙන්න වුණා නම් you can watch the initial part by the recording, right? I will share the recording as soon as possible. Do the calculation. හරි බලමු. Okay. A 2 cubic decimeter of a solution contains 4 moles of sodium hydroxide. Find the sodium hydroxide concentration. That is super easy because you are given the number of moles as well. C equals N over V. So the number of moles is 4 moles and the volume is given as 2 cubic decimeters. So that is 2 moles per cubic decimeter. 2 moles per cubic decimeter. Hari. Do the next one also. Then you are asked something else. ටිකක් කල්පනා කරන්න වෙනවා. What is the mass of glucose required to prepare 1 cubic decimeter of a 2.5 mole per cubic decimeter glucose solution? දැන් අහන්නේ what is the mass කියලා. හිතලා හදන්න බලන්න. You can. Yes, I can කියලානේ පටන් ගන්න. What's the answer? Sesandi, what's your answer? 450 grams. Then, this was finished. What's the answer? Yes. Oh, hadapu දාන්න බලන answers. This is 450. Muri says 450. The three of you had mentioned the same answer. Manuti says 450. Janindi says 450. Aina hariyadine. Andrea says 450. Then it may be correct. Since all of you have got the same answer. Limansa says 450. The Madhadana de Gudnane, Ranu says 450. Let's see. Mass of glucose. So glucose is C6H12O6. You are given the relative atomic masses. You can calculate the relative molecular mass. Here 12 into 6. Here 1 into 12. Then 16 into 6. Relative molecular mass. Here 36 plus 12, 48 plus 96. එතකොට 12 into 6 කොහොමද 36 වෙන්නේ 12 into 6 is 72 plus 12 එතකොට මෙතන altogether 180 නේද the relative molecular mass is 180 so once you take the relative molecular mass in grams that is equal to the molar mass දැන් අපි පටන් ගන්න ඕනේ C equals N over V right so C is given 2.5 moles per cubic decimeter. Moles per cubic decimeter equals number of moles we don't know. The volume is given as 1 cubic decimeter. This is the solution we need. එතකොට number of moles equals 2.5 moles per cubic decimeter. මම මෙහෙම ලියන්නේ to show the units. Into 1 cubic decimeter. So per decimeter, per cubic decimeter. Therefore, the number of moles equals 2.5. හරිද ඔන්න ලකුණු දෙකක් හම්බ වෙනවා 2 marks. ඊට පස්සේ then you know another equation how to convert the number of moles into a mass, right? You know the number of moles equals mass divided by the molar mass. Now you are asked about the mass. Mass equals number of moles multiplied by the molar mass. So number of moles equals 2.5 moles. 2.5 moles multiplied by the molar mass. Relative molecular mass taken in grams. Relative molecular mass taken in grams is the molar mass. Right? Mole per mole. The mass equals 180 into 2.5. 180 into 2 can 360. 0.5 can half. 90. 360 plus 90 is 450. 450 grams. හරිද? කබලන answer එක ගත්තා මට අයවපු answers ඔක්කොම තිබුණේ 450 කියලා. Hands up those who got the answer. Hari, most of you have got. Then hari ned මෙන්න මේක grade 10 knowledge. This part. This one learned today. Okay, after taking this down do the next one also. හොඳට කල්පනා කරලා හදන්න බලන්න. ප්‍රශ්න තියෙනවා නම් අහන්න. Yes, Chanel, Kian. What did you ask? Sodium. ඊළඟ එකේ තියෙන sodium hydroxide ද? Shall I erase this? මේක ඉවරයි නේද හැමෝම? Work out the mass of sodium hydroxide that should be weighed to prepare 500 cubic centimeters of 1 mole per cubic decimeter sodium hydroxide solution. Hydrogen equals 1, oxygen equals 16, sodium equals 23. Mass of sodium hydroxide. किए दावे? Yes. Hmm? That should be weighed to prepare 500 cubic centimeters of 1 mole per cubic decimeter sodium hydroxide solution. So once again you can find the number of moles by using this number of moles equals concentration multiplied by the volume. So the concentration is 1 mole per cubic decimeter. 1 mole per cubic decimeter. And 500 cubic centimeters means 0.5 cubic decimeters. And that understanding is required. The unit conversions. 500 cubic centimeters means 0.5 cubic decimeters. Per cubic decimeter, cubic decimeter. Therefore, the number of moles equals 0.5 moles. Right? 0.5 moles. So, you are asked about the mass of sodium hydroxide. Then we can calculate the relative molecular mass of sodium hydroxide. Hydrogen is 1, oxygen is 16, sodium is 23. So altogether this is 40. Neither 40. When the relative molecular mass taken in grams, that is the molar mass. Therefore, you can substitute for the equation number of moles equals mass divided by molar mass. Right? So the mass is equal to number of moles into molar mass. හරිද? මේ ලකුණු හතරක් විතර ලේසියෙන් ගන්න පුළුවන් ප්‍රශ්න මේවා. Learn the method. That is easy. Right? So the mass equals number of moles is 0.5 moles. Molar mass is relative molecular mass taken in grams. 40 grams per mole. Right? Mole per mole. 40 into 0.5, that is 20 grams. You get the answer as 20 grams. Did you do that? Kabalana answers gatta hai? Just raise your hands. Anita, it yes, Metuja, what happened? Yes, Metuja. Unit conversion කරන්න ඕනේ. ඒකනේ මම substitute කළෙත් units එක. Andrea, what happened? You got. Hari. Akshaya, Sribanuja, Hadisha. Manuti, what happened? Sorry? 2 moles. Why? How come? Hari, ඊළඟ එක බලමුද? There you can do the first part. Second part, I will let you know how to prepare the solution, standard solution. Do the first part, calculate the mass needed. Have you all finished? Yes, Akshaya, finished? Adisha, Adisha, what's the answer? 10 grams. Okay, we'll see. Okay, Amadi. Ashwi Pute, I don't know. I haven't even seen the face. Can you turn on the video? Videv, did you get the answer? What's the answer? Okay, let's see. Hari, I just saw your message. What do you want me to explain once again? The second question. Hari, so the third one is also in the same pattern. So shall I do it and show you? මෙහෙමයි ඉස්සෙල්ලාම කරන්න තියෙන්නේ you have to substitute for the equation C equals N over V. From that you can find out the number of moles. Don't by heart this. Understand the method. ඊට පස්සේ you have to convert the number of moles into a mass. For that you have to multiply the number of moles by the molar mass. That's all. හදන්න බලන්න තව විනාඩි දෙකක් දෙන්නම් කලින් වැරදිච්ච අය හදන්න. මනුති ආයිසරයක් බලන්න. ඉන්දුනි හරිද? Okay, Akshaya. Okay, Janindi, Muri, Akshaya. So this type of questions have been asked in the O-level papers, right? We'll do them in the paper class. In structured essay questions, actually they have given this type of calculations. And in the MCQs also. Hari, then Balamu. You are asked to prepare 250 cubic centimeters of 1 mole per cubic decimeter sodium hydroxide solution. මෙතිර බින්දුවක් පොඩක් වැඩි. right? හරි මනුති ෂෙනෙලා okay. Calculate the mass of sodium hydroxide. එතකොට in the first part you are asked to calculate the mass. You are given the volume as well as the concentration 1 mole per cubic decimeter, and it says it is a sodium hydroxide solution. And you are given the relative atomic masses also. You can calculate the relative molecular mass So hydrogen is 1, oxygen is 16, sodium is 23. When you get the sum, that is 40. That is the relative molecular mass of sodium hydroxide. It was say, since you are given the concentration, you can calculate the number of moles. You can write the equation for concentration first. Concentration equals number of moles divided by the volume. C equals N over V. So you can find out, since you know the concentration as well as the volume, we can find out the number of moles. C into V. So the number of moles equals C. Concentration is 1 mole per cubic decimeter. This is given as 250 cubic centimeters, right? 250 cubic centimeters. So 1000 cubic centimeters is equal to 1 cubic decimeter, right? Any 250 cubic centimeters can 0.25 cubic decimeters, right? So here you can write 0.25 cubic decimeters, right? Number of moles equals per cubic decimeter, 0.25 moles, right? 0.25 moles. That is the number of moles. But we can't work with the moles. We have to convert it into a mass that we can measure. Therefore, I substitute for the equation number of moles equals mass divided by molar mass. ඔන්න equations දෙක තමයි ඕනේ වෙන්නේ. So, the mass equals number of moles into molar mass. So, the mass equals number of moles is 0.25 moles and the molar mass is 40 grams per mole. 40 grams per mole. Mole per mole, 40 into 0.25. Here, 0.25 into 4 is 1. Into 40 can 10. 10 grams. Right, mass equals 10 grams. Hurry the hands up those who got the answer. Hurry. Okay, most of you have got. Where's Ranu? Ranu hitiyane. Ne. I know. Ranu, you got, right? Okay. Shanela, what happened? Did you go wrong? Ah, no, you have got it correct. Gavisha. Okay. Kashvi. මට පේන්නෙත් නෑ ඉතින් කට්ටියව. 3 of you are invisible and Gavisha, you can't see you as well. I can see the ceiling. Hari. Then කොහොමද how to prepare the standard solution? ඔන්න ඕකත් කීප සැරයක් අහලා තියෙනවා term test papers වල නම් නිතරම අහන එක. How to prepare this standard solution? Now we have calculated the mass of sodium hydroxide needed. So how to prepare the solution, right? I will explain the method. After that, I will give you the steps. Sometimes in the question paper, they ask to write the method in 4 steps or 3 steps. So there are certain terms that you have to use definitely. And I will share a video. Write the steps that I have given here. I'm giving here. In the videos, they may be a bit different from the method that we mentioned, because in the marking scheme, they will refer to the method mentioned in your textbook. Haridan. So here, the measurement of mass is very important. The accuracy of the mass is very important, because if the method 10 grams, no, if it becomes 10.01 grams, then the concentration will be different. If the mass is 10.01, what is the concentration? You can do the calculation to the opposite side, right? It is not 1 mole per cubic decimeter. Enisa, you can see then 0.01 difference can make a big difference in the concentration. Therefore, the accuracy of the measurement of mass is very important. Right? එතකොට අපි ලියනකොට ලියනවා සාමාන්‍ය 10 grams and 10.00 grams කියලා. Right? Measure 10.00 grams of sodium hydroxide accurately by using you can use the triple beam balance, 4 beam balance, or the digital balance. And you have to measure the mass accurately. Then actually you are measuring the mass to a watch glass. In the at school you will do this practical. You take a watch glass, then clean, empty, dried watch glass, right? Clean, dried watch glass is taken, and first you measure the mass of the watch glass. You measure the mass of the watch glass. It is I don't know 7 grams. We need 10 grams of sodium hydroxide. 10 plus 7, 17. We keep this on the balance, maybe triple beam balance, 4 beam balance, and we add sodium hydroxide until the total volume becomes 17. Again, a mass of the watch glass plus mass of sodium hydroxide required. හරියටම measure කරගන්න ඕනේ. ඊට පස්සේ we take the watch glass. ඉන්න. කීයද අපේ volume එක ඕනේ? 250 cubic centimeters. 250 cubic centimeters. So in the laboratory, there are volumetric flasks of different volumes. Volumetric flask, right? So there, here we have to select a 250 cubic centimeter volumetric flask, since we are supposed to prepare a solution of 250 cubic centimeters. Therefore, we have to select a volumetric flask of 250 cubic centimeters. Volumetric flask is something like this. It has a stopper as well. Stopper and they have mentioned that this is and say 250 cubic centimeters. They have mentioned that. Right? Now we remove the stopper. Right? We remove the stopper. Then you take a volumetric flask. Then you have to take a glass funnel. Once again, clean, dry glass funnel. Right? They should be clean. I may clean කියලා කියන්නේ. නැහිතන කලින් හදපු මොකක් හරි solution එකක ටිකක් ඉතුරු වෙලා තිබුණා. It is in contact with the watch glass or maybe with the funnel. That is also added. Then the concentration varies. And we can't say then it is sodium hydroxide. So clean, dry glass equipment should be used. So you take the glass funnel, you keep it here, glass funnel. Then you have to hold the watch glass to this with sodium hydroxide. So now here there is sodium hydroxide. It is white in color, but I will draw it like this. Hold the watch glass, and then you have to wash all this sodium hydroxide. Wash all this sodium hydroxide into the volumetric flask by using a wash bottle. Right? You know, wash bottles. Wash bottles. I will draw something like this. You wash all the sodium hydroxide by using the wash bottle. Here you have distilled water, right? Distilled water is inside. So you wash all these into the volumetric flask, right? So this is the 250 cubic centimeter volumetric flask. There are volumetric flasks of 250, 500 cubic centimeters, 1 cubic decimeter likewise. Then this is the funnel, glass funnel. This is the watch glass containing sodium hydroxide. And this is the wash bottle with distilled water. Now, wash karna. Eda passe, you have to wash either side of the watch glass as well. You have to wash either side of the watch glass. If at least a tiny particle is in contact, you have to wash all these. Then you have to wash the inner side of the funnel also. But wash karala. Right? It should be something up to this. අපි කියමු 2/3 කියලා. 2/3 of the volumetric flask is filled now by washing this off. ඊට පස්සේ you have to put the stopper and dissolve all the sodium hydroxide carefully. හරි. Put the stopper and dissolve. You can shake it. සාමාන්‍යයෙන් නම් කරන්නේ එක විදිහට කරලා පෙන්නන්න පුළුවන් ඕගොල්ලන්ට. සාමාන්‍යයෙන් කරන්නේ දැන් මේක නම් stopper එක, you keep your thumb here and do it like this. We don't insert at least a glass rod. The composition can be changed because some of the amount will be taken away by the glass rod or something else can be added with the glass rod. එනිසා මෙහෙම තමයි සමහර අය මෙහෙම shake කරලත් just dissolve. Right? After dissolving, now the water level is somewhat here. Then you have to top up this. You have to top up this up to this mark. This is the 250 cubic centimeter mark. mark So this is 250 cubic centimeter mark. 250 cubic centimeter mark. So you have to keep your eye somewhere here at the same level. It should be at your eye level, right? And the lower meniscus of the liquid should be in contact with this line. Lower meniscus should be in contact with the line. Until that, you have to top up by adding distilled water. Once all sodium hydroxide is dissolved, you have to do this. හරිද? ඉස්කෝලේදී කරයි එතකොට තේරෙයි කොහොමද කියලා. සමහර එක පාරට හොස් ගාලා දානවා. එක බිඳුවක් හරි වැඩි වුණොත් ඔන්න concentration එක වැඩි වෙනවා. මේ අඩු වෙනවා. concentration එක වෙනස් වෙනවා. දැන් මේ හරියට විතර මේ add කරගෙන යන්න පුළුවන්. ඊට පස්සේ you can use a dropper. You can add distilled water dropwise. Right? You can add distilled water dropwise until the lower meniscus of the liquid comes in contact with this 250 cubic centimeter mark. Am I correct? So once you do this at school, you will get the proper experience. Hari. After preparing the solution, you can paste a label here mentioning the name of the liquid and also the concentration and the date of preparation. Right? Make it 1 mole per cubic decimeter. So in the label, you can include 1 mole per cubic decimeter. Right? Sodium hydroxide, aqueous solution, and the date of preparation. Include on the label. Right? So you can attach that label to the volumetric flask. That's all. So label the other things you have to mention. Just sketch this, leaving some space on the other side to write the steps. What the Shaneli Mahansida? That's නිකන් අර මොකද්ද කියන්නේ 18 අරන් 100ට දීලා වගේ ඉන්නේ. Yes, go Anita, Gavisha, Yuri, Adisha, Kashri, Videv. Manuti, you got disconnected, right? Man dakkina koyula disconnect une kiyala. Did you hear the method that we mentioned? Okay. Yes, finished. Hari. Yemuda. Right. Memeliamo steps. Um, so first one, accurately weigh mammalian. 10.00 grams of sodium hydroxide using a triple beam balance 4 beam balance, or the digital balance. Accurately weigh 10.00 grams of sodium hydroxide using a triple beam balance or a 4 beam balance or a digital balance. Right? Next point. Take a 250 cubic centimeter. Take a 250 cubic centimeter volumetric flask and a clean funnel and a clean funnel. The second point. Take a 250 cubic centimeter volumetric flask cubic centimeter volumetric flask and a clean funnel There, according to the question, if you are asked to write in 3 steps, you can summarize into 3 steps. But you can summarize. Sometimes they will ask to write in 4 steps, 3 steps. So based on the question, you can do that. Next point. Transfer the weighed sodium hydroxide. Transfer the weighed sodium hydroxide red point තමයි මේ කියන්නේ නේද? Transfer the weighed sodium hydroxide completely through the funnel. Transfer the weighed sodium hydroxide completely through the funnel using the wash bottle. එතන දාගන්න transfer all කියලා දාගන්න transfer all the weighed sodium hydroxide all. එතකොට එතෙන්දී ඔන්න I mean that you have to wash either side of the watch glass and the funnel. ඒ ටික මම ඔන්න ලියන්න යන්නේ නැහැ. හරිද? In the past years when they asked in the marking scheme also they did not include that, but you have to say transfer all the sodium hydroxide, transfer all the chemical. And then you have to wash the surface of the watch glass and the inner surface of the funnel, right? The next point, add about 2/3. Add about 2/3 Add about 2/3 of the required volume. Add about 2/3 of the required volume. Add about 2/3 of the required volume. Of water and stopper the volumetric flask. And stopper the volumetric flask. Stopper කියන්නේ cover it with the lid කියන එක. Stopper. Stopper the volumetric flask. Then shake the flask. Shake the flask to dissolve all sodium hydroxide. Shake the flask to dissolve all sodium hydroxide. To dissolve all sodium hydroxide. Then last point. Keeping the eye at the level of the volume mark. Keeping the eye at the level of the volume mark. Add distilled water carefully. Add distilled water carefully. Until the lower meniscus. Until the lower meniscus is at the level of the volume mark. Is at the level of the volume mark. Then finally you can say paste a label including you have to stopper the volumetric flask and paste the label, right? Paste a label including the volume, sorry, the concentration, name of the solution, and the date of preparation. You can't write all these for the as the answer, right? එතකොට මෙතන අනිවාර්යයෙන්ම expect කරන දේවල් තමයි you have to measure the mass accurately. by using the triple beam balance or the 4-beam balance. Measure the mass accurately. It was a transfer all the sodium hydroxide or the whatever the chemical substance, transfer all into the volumetric flask by using a wash bottle, right? It was a dissolve all sodium hydroxide. ඊළඟට make the final volume 250 cubic centimeters by adding distilled water. අනේ steps ටික තිබ්බනම් ඇති. ඒ විදිහට summarize කළා නම් ඇති. Measuring the mass accurately, transfer all sodium hydroxide, ඊට පස්සේ dissolve all sodium hydroxide, then make the final volume 250 cubic centimeters by adding distilled water. ඔන්න ඔය ටික කිව්වනම් හරි. මහන්සිද? වීඩියෝ එකක් බලලා ඉන්නවද? පොඩි බ්‍රේක් එකකට ගිහිල්ලා එනවද? මොකද කරන්නේ? Do you want a break? Yes. හරි විනාඩි දෙක තුනක් දෙන්නම්. 11:38. ඉක්මනට ගිහිල්ලා වතුර ටිකක් එහෙම බීලා එන්න රස්නේ වැඩිනේ මේ දවස්වල නේද? Then I will share the video. If you have returned, please raise your hand. Please raise your hand if you have returned. Where are the others? And did you all come back? Please raise your hands. Those who have returned. ඉස්සෙල්ලා භාගයක් විතර තමයි හිටියේ. Hari. Shall I share the video then? So this may be slightly different from the steps that we wrote, but watch the, just get an idea about the method. So this is the digital balance, right? So that is somewhat different from the one which mentioned in the method. So better to use a watch glass instead of a beaker like this. We can use a watch glass for this. We don't need to transfer it again and again. No. ඉන්න බලන්න මේකේ දෙකටම පාවිච්චි කරලා තියෙන බීකර් එක තමයි. බීකර් එකකින් ආයි volumetric flask එකකට transfer කරන්න ඕනේ නැහැ. Then you can see that certain droplets will remain in the beaker also. Enisa, it's better to use a watch glass and a volumetric flask for this rather than doing it like this. එතකොට මෙතන contamination වැඩි නේද? අර container එකෙන් to the beaker, then beaker to the funnel and the volumetric flask. So you can do it directly. That is the way of dissolving. Here you can see the line on the volumetric flask. This is the mark, right? Hari, just have a look at this as well. No. So that's why I told at the beginning that these may be different from the method that we mentioned. So what we have to do this, minimizing the contaminations, right? There he did not mention how to top up. So in the previous one, you saw how to top up the bottle volumetric flask until you reach the exact volume. Hari. Then Harine, the method calculation part. Hari. When preparing a solution of a specific concentration, following factors should be taken into consideration. One other, cleanliness of all the equipment used, right? Then weighing the solute accurately. Then washing well and transferring the substance, sticking to the watch glass and the funnel into the flask. That is why we washed both of them. Use the correct technique for mixing. We don't use a glass rod. Adjusting the final volume carefully by using a dropping pipette or a dropper. You can just add distilled water dropwise to top up the last few drops. Prevention of the entry of impurities into the solution. That is why we don't even use a watch glass and we use clean glassware. Hari. මම තව calculations කීපයක් දීලා තියෙනවා කරන් බලන්න fourth one first. Fourth one. This one. Turn on your videos for the rest of the 35 to 40 minutes. පැහැදිලි නැත්තම් අහන්න. දැන් අදින් පස්සේ මේ ගණන් හොඳට පුළුවන් වෙන්න ඕනේ. එච්චරයි. So you have to do the clarifications now. Yes, finished? Hands up those who are still doing. The fourth one, I mean. Still doing. හරි බලමු. හරි let's check your answers. දැන් ඇති. What is the mass of potassium carbonate required to prepare 500 cubic centimeters of the potassium carbonate? So what is the formula of potassium carbonate, Janindi? Yes, K2CO3. K2CO3. So you are supposed to prepare 500 cubic centimeters of 1.5 moles per cubic centimeter potassium permanganate, sorry, potassium carbonate solution. Hari. එතකොට මේ mole 1 mole per cubic decimeter කියන එක 1m කියලාත් ලියන හැබැයි O level papers වල නම් මම දැකලා නැහැ. A level වල පාවිච්චි වෙනවා 1m කියලා capital M. හරිද? එතකොට මෙතන K2CO3 16 into 3 that is 48 නේද? Carbon is 12. Then K2 potassium is 39 into 2 that is 78 නේද? So altogether 138. 138 is the relative molecular mass, right? Then you are asked to calculate the mass. So you have to find out the number of moles. C equals N over V. N equals C into V. So the concentration is 1.5 moles per cubic decimeter. And the volume is given as 500 cubic centimeters means 0.5 cubic decimeters, right? 0.5 cubic decimeters per cubic decimeter. So the number of moles equals 1.5 into 0.5. That is 0.75 moles. 0.75 moles. හරිද තෙසිනි? Chanela, Muri. Then the number of moles equals mass divided by molar mass. Therefore, we know the mass equals the number of moles into molar mass. Number of moles 0.75 moles, right? And the molar mass is relative molecular mass taken in grams, 138 grams per mole. So the mass is equal to 138 into 75. එතකොට 2 decimals 106.50 grams. ආවද මෙහෙම answer එක? Did you get? හවුද? නැද්ද? No? Hands up those who got. Did I make any mistake? 138 into 75. Yes, yes? 102? Let's see. හරිනේ මෙතන 690. මෙතන 6 නේ. දැන් හරිනේ? 103, right? 103.5. Did you get the answer? 103.5. Hands up those who got 103.5 grams. Okay. The same method, right? Find the number of moles, then convert it into a mass. Number of moles into molar mass. හරිද? ඊළඟ එකත් හැදුවද? Did you do the fifth one also? හවුද නැන්ද? කිව්වේ නෑනේ නේද? හරි දැන් කලින් එකට තරම් වෙලා ගන්න එපා. ඉක්මනින් හදන්න ඊළඟ එකත්. දැන් ඒක පොඩ්ඩක් ඔන්න මෙතඩ් එක වෙනස් වෙලා ටිකක් කල්පනා කරන්න ඕනේ. ලේසි හැබැයි ඒක ගාන අනිත් පැත්තට හදන්න තියෙනවා. Backwards. You are given the mass. Yes, finished. Hands up those who have finished. Three, 4, 5, 6, 7. The others are still doing, right? I will give you another 1 minute. බලන්න answer එක ගන්න කොහොම හරි. Then if you have gone wrong in some of the previous calculations, just do them once again at home, right? හරියනකම හදන්න ආයිත් සැරයක්. හරි බලමුද? Shall we check? බලන්න to a 500 cubic centimeter volumetric flask. 9 grams of glucose was added. Glucose was transferred and distilled water was added until the total volume of the solution is 500 cubic centimeters. Right? What is the concentration of the solution? So this is C6H12O6. So you have to calculate the relative molecular mass. So here 16 into 6, 96. Here 1 into 12, that is 12. Here 12 into 6, that is 72. So altogether 180. That is the relative molecular mass of glucose. Right? ඔන්න දැන් අපිට පටන් ගන්න වෙන්නේ with the mass. Right? We have to find the number of moles. දැන් අනිත් පැත්තට කියලා මං කිව්වේ we are doing the calculation reverse. Mass divided by the molar mass. So the number of moles equals mass is given as 9 grams. Molar mass is 180 grams per mole. මේවා කටපාඩම් කරන්න යන්න එපා. තේරුම් ගන්න දීලා තියෙන data අනුව number. We are given the mass, we have to find the number of moles. If we are given the number of moles, we have to calculate the mass. So here 9 divided by 180 කියලා කියන්නේ කීයද? 180 into 5 is 900 නේද? එතකොට 9 letter 0 90 0 900 it is 5 per mole, that is mole 0.05 moles. Did you get this? මේක ආවද? මේ 1 over 20 නේ 1 over 20 that is 0.05 moles. ආවද? හවුද? දැන් ඔළුව වනා ගන්නවත් පණ නෑ වගේ සමහර අය. හවුද? ආවනේ? හරිද? ඔළුව වඩන්න ගියාමත් එනර්ජි යනවානේ නේද? Then you are asked to calculate the concentration. So concentration equals number of moles divided by the volume. So number of moles is 0.05 moles and divided by the volume 500 cubic centimeters. So 500 cubic centimeters equals 0.5 cubic decimeters. Right, 0.5 cubic decimeters. Cubic decimeter. එතකොට මෙතන මොකක්ද? 0.05 into 10 is 0.5. 1 over 10 කියලා කියන්නේ 0.1 mole per cubic decimeter. 0.1 mole per cubic decimeter. Hands up those who got the answer. බලන්න. Yes. හරි වැරදිච්ච අය තියෙනවා. කලින්ට වඩා ලේසි නේද? දැන් මේ පැත්තට හදන්න. හ්ම්? හරි. ඊළඟ එකත් බලමුද? එතනින් ඉවර කරමු. අම්මෝ දැන් නම් මූණෙත් අත තියාගෙන ඉන්න. ඉවර වෙන්නේ කවදද කියලා. මේ ගණන් එනවා ඈ. O level paper එකේ දීලා තියෙනවා. ඒ නිසා ප්‍රැක්ටිස් කරන්න. මහන්සි බලන්න නැතුව තව එකක් හදමු. හරිද? කාට හරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න. chat එකට දාන්න අහන්න බැරි නම්. Equations දෙකයි හැමතිස්සෙම use කරන්න. In addition to that, you should know how to find the relative molecular mass and convert it into the molar mass. That's all. Finished? හරි බලමුද? තාම හදනවා පේනවා. දැන් පොඩි රෙස්ට් එකක් අරගෙන ක්ලාස් එකෙන් පස්සේ අද දවස් ඇතුළත ආයි මේ වැරදිච්ච ටික ආපහු හදලා බලන්න. හරිද? ඉක්වේෂන්ස් තියෙන්නේ කීයද? n m over m v over v n over n හරිම ලේසි. ඊට පස්සේ m over v ඊළඟට concentration. These are the 5 methods by which we express the composition of a mixture. Drink more water these days. It is too warm and sunny. Neither. The loss of water from the body is high. Therefore, you have to drink a lot of water rather than the other days. Hari, shall we check? What is the mass of relative atomic mass? What is the mass of magnesium chloride required to prepare 500 cubic centimeters of 0.5 mole per cubic decimeter magnesium chloride solution? So magnesium chloride is MgCl2. Magnesium is 24. Chlorine is 35.5. Right? So chlorine 35.5 into 2, that is 71. Magnesium is 24, that is 95. Relative molecular mass is 95. Harida. Then so you are given the concentration and the volume. C equals N over V. So you have to calculate the number of moles. Concentrate N equals C into V. Concentration into volume. Concentration is 0.5 moles per cubic decimeter. When you substitute along with the units, you will not go wrong. එතකොට ඔයාලට පේනවා දැන් වැඩි වෙලාවත් cubic centimeter වලින් substitute කළොත් පේනවා මෙතන තියෙන cubic decimeter කියලා. Right, that is 0.5 cubic decimeter. එතකොට 0.5 into 0.5, 0.25 moles. Right? Then the mass of magnesium chloride needed. So number of moles equals mass divided by molar mass. Therefore, the mass equals number of moles into molar mass. The number of moles is 0.25 moles and the molar mass is 95 grams per mole, right? So 95 into 25. So what it is? 23.75 grams. Did you get? Avada? Hmm? Avada? Hari. Then පුළුවන්නේ වැරදුන්න ඒවා තිබුණොත් කලින් තිබුණා නම් කලින් නෑ. This is number 6, question number 6. So you can do the previous calculations. The concentration of a solution can be lowered by adding more solvent. හරිද? දැන් අර කෝඩියල් එක වගේනේ. If we need to reduce the concentration, we have to add more water. So if we need to reduce the concentration, we have to add more solvent. Decreasing the concentration by adding more solvent is known as dilution, diluting a solution. Most of the acids in the laboratory stores are concentrated. අපි එදා කිව්වා කොහොමද how to dilute an acid කියලා. Mostly the acid solutions prepared by diluting those concentrated acids are used for laboratory experiments. We use dilute acids for most of the laboratory experiments. හරි නේද මේ ටික? Right. As a safety measure, when diluting concentrated solutions, always the acid should be added to water. Add acid into water. Is because the dilution of concentrated acids is highly exothermic. If we put water into the acid, it will explode. Therefore, it is dangerous. Therefore, you have to add acid into water. හරිද? එහෙනම් අපිට ඊළඟ දවසේ අලුත් topic එකක් තමයි පටන් ගන්න තියෙන්නේ. Separation of components in a mixture. Right? That is also somewhat lengthy, the separation technique. අපි බලමු පුළුවන් තරම් කතා කරන්න. හරිද? Meanwhile, I didn't do the questions that I started. මම හිතන්නේ first unit එකේ මම homework ටිකක් දුන්නා ඔයගොල්ලන්ට. නේද? අර questions unit test. එහෙමනේ දුන්නා නේද කරන්න කියලා. හරි. ඒ ටිකත් අපි බලමු ඊළඟ දවසේ එක දිගටම separation techniques කතා කරන්න අමාරුයිනේ. But time to time I will take these questions, and from the second unit also I can give that set of questions. හරි. එහෙමනම් ඉතින් අද කරපු ටික හොඳට බලන්න, මොනවා හරි ප්‍රශ්න තියෙනවා නම් අහලා එවන්න. ආපහු ගණන් ටික හදන්න. දැන් ජනවාරි අදින් ඉවරනේ. ජනවාරි month එකේ කැලෙන්ඩර් කොලේ ගලවගෙන. හරිද? ඒ කියන්නේ අනිත් පැත්තේ ගණන් ටික හදන්න ආපහු සැරයක්. හරිද? අපරාධනේ කොලේ අයින් කරන එකකින් වැඩක් ගන්නත් එපා. ඔයගොල්ලෝ දැන් හදපු answers ටික වහගෙන අයිත් සැරයක් do the rough work. හරිද? Lazy method එක practice වුණාම don't by heart, understand the theory. Number of moles නම් you have to convert it into a mass. If you are given the mass, convert it into the number of moles, then to the concentration. හරිද? ඒ විදිහට practice කරන්න. නම් අපි ඊළඟ සතිය හම්බ වෙමු, and refer the schedule for තව ටිකක් දවස් තියෙනවානේ. School holidays හම්බෙන් you have 2 more weeks. For the O level batch we have 2 more days to do the class. හරිද? ඒකෙන් තව දවස් දෙකයි ඊට පස්සේ ඉවරයි. Okay then. ඔයගලන්ටත් එහෙම එනවා. ඒ නිසා දැම්ම ටික ටික වැඩ කරන්න. Okay. See you on next Saturday. Stay safe and have a nice time.